All right, so hello everybody on Twitch. JRB is joining me today to talk about feature neutralization with different implementations of linear models. Let's just make sure that we're actually streaming. Yeah, we are. Good, good, good. So welcome, and thanks for joining us, Fox. Always appreciate your presence. So this is the genesis of this office hours special session. You know what though? Before I get started, this actually is a rare opportunity to do a poll in Twitch as to the daily scores because they're not out yet. So I think I should do that. Honeycomb, I appreciate you asking. So the question in Twitch is going to be earn or burn.
Always earn.
It's always fun to do this. Let's see how right we are or not. This is going to be relative to yesterday. This is always fun. Okay, so I'm going to post that. It's a 10-minute poll, so if you join a little late, you have time. You have time to do that. So anyway, back on topic. Thanks, Honeycomb. I appreciate that. In my econ classes, I was taught that ordinary least squares is an unbiased estimator, assuming that the data and the features that you're using are uncorrelated, they're centered, blah, blah, blah. All the normal stuff that we're used to hearing about OLS being this unbiased estimator. If your inputs are multicollinear, which we know that our feature columns do have multicollinearity, then OLS has a lot of problems. And so with all the feature neutrality discussion that we've been having, I'm like, why are we using OLS when we know the data has multicollinearity? And so that statement out loud got me in trouble. Okay, because that means now I have to prove it. So the whole thing led to me writing a couple of notebooks and implementing different linear models that are regularized, that hopefully deal with a bit of the multicollinearity. And JRB, my dear friend, who always calls me out on my shenanigans and disrupts my priors, which I greatly appreciate him doing so, volunteered to help me out. And so I'm very grateful for that, JRB. One thing that you were talking to me about was how the Gauss-Markov theorem fits in. So why don't you take it over from there, and I'll post a link in the various places so people can follow along.
Sure. Yeah. Gauss-Markov theorem is probably one of the more famous theorems in statistics, and for the purpose of this discussion, it essentially states that as far as unbiased linear estimators are concerned, you can't really do better than OLS. But as Arbitrage was saying, OLS comes with its own set of problems. So we could possibly use something slightly worse than OLS and hopefully get better results. And I think that's the purpose of this entire exploration. Arbitrage wrote all the notebooks. I've looked at them, but I haven't written any code. Somebody's going to be doing the talking.
JRB is the developer, and so he approved my code. So I'm grateful for that.
Yeah. How can we make linear estimators slightly worse? So one of the standard techniques is what's called the shrinkage methods, where you try to add penalties to the weights or the coefficients that are learned with linear regression. And this is fairly fundamental to machine learning and very universal. You can add penalties to your XGBoost models, and you can add them to your neural nets. So I guess some exposure to this would help, regardless of what modeling techniques you're using.
If I could also just interject 1 second, JRB. So I also talked to Michael Aller about this. He did point out that the only way to be feature neutral is to use OLS to do so, because anything other than OLS adds feature exposure or fails to reduce it all the way, right? And so OLS is the baseline. That's it, full stop. You want to achieve no feature exposure, you use OLS 100% proportion with the code snippets that we've been using. And so when you say that a linear model that we're talking about is worse, rather it's just not reducing the feature exposure to zero. It's not. I don't. Maybe I don't like saying that it's worse. Yeah, the objective function is modified, but we don't know if it's better or worse. We're suggesting that people experiment with different implementations to find out if in live rounds if it does improve the performance of a neutralized model. Right?
Yeah, that's a good caveat because we don't know how these things work in production. None of us has tried it in production, and the standard caveats apply. So that being said, I think when it comes to regularization techniques, we could probably start with Ridge regression, which is essentially a penalty on the coefficients that are the coefficients for the linear model. And the penalty essentially is on the squared sum of weights, right?
Okay.
So intuitively, Ridge regression keeps the coefficients small. Right? And the other technique that you could use is something called Lasso, also known as L1 regularization.
Right.
Where the penalty term is the sum of absolute values of your coefficients. So just going from squares to absolute values completely changes the performance characteristics of the regularization. And so people who use neural nets are probably quite familiar with this. It's like going from a mean squared error to mean absolute error. Right? I mean, that's essentially what this is. So Ridge keeps your coefficients small, and Lasso keeps your coefficients sparse. So it's quite frequently used in feature selection because it'll give you a sparse set of weights, which will only pick the most useful features.
Potentially.
And you could also do something in between, which is essentially what elastic net is.
Right.
You can have a little bit of L1 and a little bit of L2. And so I think you should probably start by showing the notebooks.
Yeah, and I intend on doing just that. There. So the first link I'm going to post goes to my Twitch GitHub. Okay, this is the baseline example predictions without feature neutralization. I implemented that by setting the proportion to 0, and it has all the outputs at the bottom. So that's that. Let me just find the best way to do this. I think probably I just share my screen like this. I'm going to move us out of the way. Bye-bye. So we have our baseline. All right, yeah, this is going to work just fine. So for those of you following along on Twitch, Zoom users, you're going to have a tough time seeing it, but let me just post that link for y'all too. If I can find my chat window. Okay. Right. At the top, first things first, I'm not training a model. Okay, I'm taking the example predictions and I'm importing those example predictions. Since it already contains validation and predictions on validation, that makes it easy for us to use. And since everybody can get access to the exact same file, I thought it was fair to use that as a comparison tool, right? You may be familiar with my data type dictionary that I import from JavaLib. That comes from my Feather series. It just makes it automatically import the feature columns as float 32. So it reduces the size a little bit. So we import our tournament data, and then we're going to implement feature neutralization code. This has been out in the wild for a while now, so this is not new. This hasn't changed at all, but it will, and I'll show you where. Right? I want to add a prediction column from the prediction file to the tournament file. So I do that in this line. Next line, I take a group by statement to create the neutralized predictions. In this case, I'm just doing a baseline 0. I'm not neutralizing at all. It's just easier to implement so that framework was all the same. Right? And again, when you do this neutralization code, you've got to get it back into the 0-1 scale. So that's what's happening here. I filter using pandas just to get the validation data on data type. And I just do that with string and take out the validation. Okay? Next, this cell takes all the metrics and graphs per era performance, and it looks at various metrics that we want to see, right? So this, again, is no feature neutralization so that we can just compare it when we go along, okay? So our maximum drawdown, which is the lowest score that we observe, is negative 3.5% for the example predictions. Average correlation, 2.56%. Median, 2.8%. Right? And the other one I look at is Numerai sharp. So the Numerai sharp is annualized, so you may see this different from what perhaps you're used to seeing. But our Numerai sharp is 1.97. Okay? The other important thing is our feature exposure. Average feature exposure is 8.9, basically 8.9%. This comes from JRB's code in the forum on feature exposure. At maximum is really what I'm looking at here. So what I want to do is, this is something I do just for comparison's sake, is I'm going to take just a capture with this snipping tool so that I can drag it in. Right? So now I have the metrics from the baseline. Okay? And now let's look at feature neutralization at 100% proportion using OLS. Right? Let me just scroll up so you can see this. Again, I take the prediction file, I take it against the validation data from the example predictions, and now I have a proportion of 100%. So I'm fully neutralizing this prediction set. I'm doing 100% instead of a proportion because I think that's a fair comparison to make. I'm going to do 100% for all the different regularized linear models. Right, so the step's the same. We just filter out to the validation data and then run it through the metrics. And at the bottom, we get an output that we can now compare side by side. Okay? And you'll notice our maximum drawdown. I can't see it because it's behind my camera, but maximum drawdown has fallen quite a bit. So we go from a 3.5% drawdown to a 2.4% drawdown. So that improves quite a bit. Also, the number of negative eras, there's just one. that appears to be helpful. Check out our Numerai sharp. Numerai sharp jumps to 2.53 from 1.97. But look at the feature exposure. So average feature exposure is 0. That's exactly what it's meant to do. Compared to 8.8 and maximum of 27%. Now we go down to 2.4% maximum feature exposure. So that's a big difference.
I
ahead,
think we must add that Arbitrage annualizes his
I do, yes.
sharp numbers. So yeah, I don't do that. So
I annualize everything because
high. Yeah,
that's because that's my domain experience. My domain experience says you should annualize numbers for comparison's sake. Put everything in the same unit and the same time scale.
Fair enough.
So since we have multiple month-long eras in here, I just take it straight to the annualized. I think that's just what I do. So yeah, if you don't annualize your data, it's going to look different. But that's what I do, and the code that I've provided has it annualized as well. Okay, so we see OLS gives us, from Michael Oliver's perspective, he says this is feature neutralized because OLS is the model that feature neutralization is based on. Anything else is going to add feature exposure. And that's to JRB's point about it being, he calls it a worse model. I just say it's different, and it takes a little testing. So, next one. Which one do you want to do next, JRB? You said
I think we
Ridge,
should start
right?
with Ridge, right?
Okay.
Yeah.
Let me just grab the link for the folks. So if you're following along, here's your Ridge notebook. Okay, all these are open source. You're welcome to download them. Use them as you see fit. There, I'll post it in Zoom chat too. Okay. Now, let's look at Ridge. Again, for comparison's sake, I'm doing 100%. The proportion is set to 1. And in terms of metrics, let's take a look at that. We still have that one negative era. Let's compare it to the baseline. Okay, let's get side by side. 1 second. Right. Maximum drawdown, 2.52%. Our Numerai sharp is 2.63. So we've improved Numerai sharp by using Ridge. But at what expense? Well, it's because of feature exposure. So here, if we look at the Ridge model, it's giving us a 1.05% average feature exposure, and maximum is 2.44. So we are introducing a little bit of exposure, even though the proportion is 100%. So JRB, what's your take on that?
Well, what was your lambda? I think you should probably just scroll up to. So Ridge introduces an additional hyperparameter. I don't know if it's called lambda or alpha.
Oh, I see what you're saying.
Which is essentially the strength of the penalty.
Let me zoom in a
Right?
little bit.
So
make it easier for people to see. It's going to blow up my my code here, but yeah, here's where it is. So I import from scikit-learn linear model, right? And I use Ridge. I set the alpha at 10, fit intercept false, normalize true.
right. Okay. So yeah, one more thing to remember with Ridge and also Lasso is that you have to normalize, essentially center the data. So sklearn is really nice where it just does it for you. I'm not really sure if other packages do it, but yeah, you should always remember to center your data before you use Ridge or Lasso or a combination of the two. It's actually optional with the OLS. You can get away with not doing it. But yeah, so the best part about OLS is there are no parameters to tune, right?
Correct.
You just plug the thing in, it works. Well, the
It's
neutralization
plug and play.
code has this parameter called proportion, but otherwise there's nothing. With Ridge, you will have to do some searching to find the optimal value for alpha. So essentially, the bigger the value of alpha is, the smaller your weights tend to be. So the stronger the regularization is. And yeah, so I don't think we've done any searching here.
I may have
I didn't
tinkered with
use
it a little bit, but when I saw Numerai sharp go up, I said, okay, that looks good. I didn't
Yeah.
want to go through and try to optimize it because that wasn't really the purpose of today's stream. Today's stream is just simply to give people a framework to look at and try on their own. I hope a lot of people experiment with this, especially if they have additional model space to upload prediction sets with different types of feature neutralization methods.
And also, one of the things I've learned lately is that better validation metrics don't necessarily correlate with better metrics on live. So yeah, everybody gets 15 slots, make the best of it.
That's right.
Try as many experiments as possible. Yeah, so I think that's pretty much the only thing I wanted to say about Ridge.
Okay.
Try different parameters for alpha.
Yeah.
And pick something which works.
Right. So you'll notice that the code's a little different. I did want to show a little bit on the code. We're predicting in sample. Okay, so their linear model in sample, this is a new line. I kind of made it a little different. I'm subtracting it out, and you'll see. So I take scores, which are the predictions, minus the proportion, which is 1, times the in sample. So I'm just taking out the in sample prediction here, and then I'm returning a normalized score. That's what's happening. And so this was rather easy to implement. It wasn't a whole lot of work. I just walked through and made it descriptive. So again, this is available in the GitHub, and I posted that link in Twitch chat. And for those following along on a recorded version, I'll make sure that wherever this is shared in the comments, I'll make sure that the notebooks are shared for you. So let me just zoom out a little bit so I can be able to compare. So now we have Ridge. And JRB, do you want to do Lasso or ElasticNet?
Well, I guess we'll go Lasso next, and
Okay.
then finally move on to Elastic.
Yeah, so let's take a look at Lasso.
Documentation.
Lasso didn't work. I remember telling JRB
Oh, right.
I wasn't sure how that was going to go, but he wanted
But,
to have a look at it. So we
reporting
did.
failures is just as important.
Yep, I agree.
I'd say
That's
it's more
called
important
science.
than reporting successes.
I call that
Right.
science, yes. Here, I'm going to post this in Zoom chat too for the folks. So here's a Lasso notebook. Lasso didn't come up with a solution that worked. You'll see the metrics are the same as the example predictions themselves without any neutralization. So it was UNCH. The solution was UNCH.
Yeah.
So that was
So
interesting.
yeah, Lasso is the second most popular form of regularization. And like I said, Lasso tends to give you sparser features. So if you look at the coefficients, it would be nice to actually plot the coefficients, but I guess we didn't have the time to do it. The coefficient from Lasso tend to be very sparse, as in you will have some big numbers and a lot of zeros, right? So Lasso essentially is a sort of a feature selection mechanism.
Well, also Lasso assumes
away...
that the data is sparse, so there's lots and lots and lots of zeros instead of having signal, and so Lasso is trying to find coefficients that matter rarely, but weight them, so that when the signal shows up, it isn't lost, right? And so this is not a sparse data set, and so that's why I didn't think Lasso would work, but JRB insisted I try it, and thankfully it was pretty easy to implement, and so I did. It just didn't find a fit, I guess. It didn't resolve. That's my guess. I didn't look into the diagnostics very much, but at least you can implement Lasso if you think it'll work for your model.
Yeah, I think in the real world, it's usually something in between Lasso and Ridge, which usually works best, and that's essentially what ElasticNet is. So if you apply,
JRB, guess what? I did ElasticNet. I have good news. I implemented that.
Was that the best?
Well, I don't know. We'll have to figure that out over time. Our naive example here, we're trying to beat what, 2.63 Numerai sharp. Let's take a look at it real quick. So what I did is I implemented I can't even say it. Stochastic Gradient Descent, and I chose the ElasticNet as the penalty. Okay, this one had a little more work to get it to plug and play, right? And it has a lot more stuff that you have to tune, so to speak. So that way we can see it. Let me just bring this up, bring us back so you can see. Put you right on the edge. So I had to make a pipeline in sklearn to make this work because, again, we have to standardize the inputs, and SGD regressor doesn't have a plug-and-play method like some of the other ones do. It also has a bit of randomness baked into it, so I had to set the seed and do all that fun stuff.
Yeah, I guess we have two comments on
Yeah,
Zoom.
I was just seeing that. Yeah, I don't know why GitHub has an issue displaying the notebook. I can't explain that.
Yeah, I couldn't open it either.
Worst case scenario, just download it locally and run it.
It doesn't work for me either. So I'm just watching it on Twitch.
Yeah, I wish I knew why that was the case.
Well, you could always clone the repository and do it yourself. And there's also a service for viewing notebooks, right? I forget what's it called.
It's called NB Viewer. I'm actually on it right now, but it doesn't work.
Oh, that doesn't work either?
That's why I kept the notebooks open locally, because I figured there might be some difficulty there. But you can certainly download it yourself and run it. And that was the intention. I'm just giving you an overview. I'd hope people would download the notebooks and use them for themselves. So I just want to explain what happens here. I had a lot of errors trying to implement this, and thankfully I hacked my way through it and figured it out. I had to use NumPy to use the ravel function to get the linear model to fit, but then this exit piece is the same, right? I had to even reshape the matrix so that I could get it to come out correctly. But I did all that work for you, so you don't have to, right? And anyway, so SG regressor, we keep squared loss, but the penalty is ElasticNet. I just kept I think the default iterations is 3000 anyway. Alpha, I think I did do a little bit of tuning on that to kind of find something that sort of worked, and the L1 ratio as well. But I set the random state to 0 because that's what the team uses. So that's why you'll see that.
Okay,
and
so my concern with using SGD regressor is that you're almost in the neural net territory. You have to tweak so many different hyperparameters. The best thing about OLS is there's absolutely nothing to tweak, right?
Right.
It just works. And you could say the same thing about Ridge and Lasso as well. There are closed form solutions to both of them. And SGD essentially is an iterative technique. And it may or may not work based on your random seeds or the phase of the moon and a lot of other factors.
That's true, yeah. It almost gets a different output every time. However, this is the best I could come up with the coding knowledge that I have, And I wanted to keep it somewhat simple. I wanted to use packages people know, and so sklearn interacts with pandas very nicely, and so I was able to keep everything kind of in the family, so to speak. That's why I did that. Now, JRB probably could write the base C++ and do your own compiling and all that stuff if you chose. I'm trying to keep it simple for the folks.
You use ready-made packages even in C++.
Oh, here it comes.
There's something called MLPack. Yeah. That's like the sklearn of C++.
Yeah, I believe you. Yes. Whatever JRB says, I do tend to believe in.
Writing anything from scratch is beyond my abilities.
I don't believe you for a second, JRB. I just don't believe you. So I kept there. Like I said, everything's the same. So we're still using example predictions. I'm still doing a proportion of 100%. I'm running through, getting the tournament file, and bringing everything back down all the way through the metrics, the output on the bottom. We now have 2 negative eras, interestingly. However, our Numerai sharp is a little bit higher. So in terms of picking a metric that is the one to end all be all, I chose sharp ratio, and technically from that metric, this is our winner. Okay. Is it what you should use? I am not saying that. Not at all. Our average feature exposure is about 1.5%, and the maximum is about 2.7%. So it adds a little bit more feature exposure, even though it's 100% proportion. Okay. I don't see a problem with that, because perhaps that's what is needed. Perhaps the solution that it finds as the best fit gives you a little exposure, and perhaps that's a good thing. I don't know. That's what I want people to find out.
Yeah. Okay. There's one thing that I want to talk about, but we don't quite have a notebook for, which is LARS, least angle regression. It's one of the newer linear regression techniques. It's essentially like Lasso, but you build it one feature at a time. So if anybody wants to look into these things, that's probably also worth exploring. And one thing which we have not talked about at all is Michael Oliver's technique of reducing feature exposure. And I don't know. Michael Oliver had a forum post about this. And so he has a very interesting technique of training a linear model and having a loss function which essentially minimizes the feature exposure. So you can give it a target feature exposure and it'll bring the feature exposure down to that level.
Yeah, you can
so
set.
I think that's
you can
really
set a
cool.
threshold. I agree. I think it's a very good idea. The reason I didn't include that today is because the implementation is very tough. It uses PyTorch, and if you're not on CUDA, the runtime is extremely long. And so, while it's endeavoring to find some level of feature exposure that may be optimal, I just wanted to stick with simple linear models. That, having run it myself on GPU for the whole prediction file, it's 2.5 hours of runtime. So it's extreme. There's no way you could put that in compute. Absolutely not. No way. Do not do that in compute. You've got to set up some kind of caching system. And so now we're adding layers of complexity, and that is not what I want to do to folks. So that's probably going to have to be yet another episode if we want to look at implementing that.
Yeah. And I've got 2 book recommendations, as I usually do.
Very nice.
Yeah. So there's elements of statistical learning. I believe it should be freely available online. And
who's the author?
The Bishop book. It's Trevor Hasty and
Hasty and Shibarani, or I can't say his last name. Yeah. I think I have that as well on PDF.
Yeah, and this is a classic Bishop book. Yeah, I think the PDF for this is also available online. Both these books have chapters on linear models, well worth reading, and they're fairly straightforward compared to the later chapters. And I'll post links to both of them.
Yeah, so there's a question in Twitch I want to take real quick. Glimpse of the Future is asking, am I going to discuss era-wise feature neutralization? That's exactly what this implementation does. So all of the notebooks that I've shared today all take a group by statement, and it's grouped by era. And so each era gets its own model fit and subtraction so that it's done era-wise and not the whole matrix at once. Lizzie Beth is asking how many hours definitely won't work on compute. If it's 2.5 hours on GPU, I have a 2080 Ti, and I think 2.5 hours is absurd. If you had to do that 15 times on a 4 CPU compute setup, I don't even want to. It's got to be days. I couldn't even guess, but too long. It would cost too much money, and I don't think it would finish on time, quite honestly.
Okay, so I must add that I managed to port Michael Oliver's code to TensorFlow and managed to bring the runtime down to about 27 minutes, which may be mildly better, but it's still pretty bad.
You wouldn't want to do that in compute.
Yeah.
Definitely not in compute.
And obviously, I think it should be okay on compute because actually, no.
No way, man.
Because
cache
if you can do this and you can cache, then you'll only have to recompute the coefficients for the live era.
I don't have a problem with that. You could implement it as is if you only had to run it for the live for 15 times. That would not be absurd.
What units are you talking about, though, when you say it takes 2 hours to do one era or
entire,
300 eras?
All of them.
For the entire test data.
The entire prediction file.
As I keep pointing out, you really only have to do one era a week if
You're correct.
you figure it out properly.
You still have to do it the first time.
You will have to.
Yeah, you got to do it once, which
model.
could take a week, but it's not. I think you're all crazy for running the whole job every week.
No, I'm not. I'm not even using it because it's too onerous.
Okay, I forgot to mention. You can essentially cache the coefficients for every era except the live one. And if you can cache everything, I actually managed to bring the runtime down from 27 minutes to about 30 seconds because it takes 30 seconds on a GPU to compute.
Yeah, see, that's the number I want. How long does it take to do one era?
Yeah.
But and with what computing power? I mean, sometimes I do things that take, 10 minutes to do an era, but that's with a single processor and I can do 40 at once. So
the problem with all this is that a lot of folks would have to completely redo their compute setup in order to implement. And if we're going to suggest that that's something to explore, then I think we should help people do that. So that is definitely not a today topic. That is a future topic. And I would love to have that set up because I think anybody would benefit from having a caching set up in their compute because it should reduce the runtime for everybody. Because we're only predicting one era and neutralizing one era at a time.
Are the proposed revamp of compute that I've heard rumors of? Or is that too off topic?
How convenient. Let's put Anson on the spot. I think that's a wonderful segue. I like it.
Wait. I want to bring Noah on.
He's connecting to audio.
He's coming. All right. Let the man himself speak.
That's great.
We promise we won't spend too long on this. I know this is supposed to be about OLS.
All of this is related, so it's on topic. That's the wonderful thing about it. Oh, don't forget, Noah, you're still muted, my friend. There we go.
Okay, so the revamp of compute. We have a few things on the roadmap. Like the first version is going to be kind of this ability to deploy multiple nodes into your compute cluster. But later on, we definitely want to add the ability to configure GPU instances, adding like storage configuration, so you can do either online or offline storage for your instances. So it would kind of enable all these ideas that you're talking about of doing like highly parallelized caching, cached algorithms for your data science.
Cool. So I always love to ask, what's the timeline look like?
So hopefully before the end of the quarter.
Wow.
For the initial release.
So it's pretty advanced. You're pretty far into it then if you're able to say something like that.
At least the initial release, yeah.
Cool.
I mean, the those other components will come probably like a few months later, probably Q2, I would say.
Okay.
But yeah, I mean, like huge, massive updates to compute. I already have up on like a branch.
Mm-hmm.
So yeah, we're kind of just waiting on like some final pieces and testing to fall into place.
Right.
Then we're gonna kind of do a big push.
I like it. Hey, thanks for that. Definitely wasn't on the agenda today, but we were able to fit that in there. So I'm just catching up on some of the chat items real quick. 1 second. Okay, yeah. So I'm also getting comments in RocketChat that the Jupyter notebooks, even when you download them locally, still aren't rendering. I don't know what to say about that, except I'll fix it. So I was able to show you in Twitch at least what the structure looked like, but I'll make sure that everybody can utilize these notebooks. So I'll make sure that's taken care of. I did want to see if anybody had questions out there as to some of these implementations or more technical things. Also, welcome, Alex. Thanks for hopping on today. Didn't get to welcome some of our newbies.
Hello, thank you.
It's user Aventurine, so thanks for joining us. Glimpse of the Future does have a question. How much feature neutralization or feature exposure? Oh, I see. How much feature exposure is bad feature exposure? Or how much to reasonably decrease it to? We don't know. If you notice Michael Oliver's feature exposure clipping tool, which was posted in the forum, kind of just sat there for a while. Nobody talked about it. Nobody really looked at it. But he sets it to 0.1 so that the max feature exposure in any given era for any given column is a maximum of 0.1. There's some sensitivity analysis to be done for sure. And I would encourage you to try that out on your own because, as Richard has said, feature exposure is risk. So the more feature exposure you have, the more risk you're introducing to your submission file. So we saw that the example predictions have a max feature exposure in the validation set of about 0.27. That might be too high. You may want to reduce that. How much? That's an open question. And I think that there's enough of us willing to experiment that we can perhaps come up with some range. And I think it's also model dependent. So I can't give you a number. I can just encourage you to try it out with some of your additional model spots and upload it and see what happens and do some testing over time.
I think it's actually deeper than that.
Oh, really?
So
I'm not surprised that you'd say that, though. I'm just not surprised.
Because we look at feature exposure as a sort of an aggregate metric, right?
Yes.
But then when you look at models which do well in a certain era and the models which burn, you can have models with the same feature exposure, and yet they perform differently.
Yep.
Right? And you see differences in the exposures per feature group. And I think this is something which Yuki was talking about.
Yep.
He's the person who actually came up with this idea that dexterity is probably a momentum-based feature group. And you have times when models which have high exposure to dexterity do really well. We're just speculating here, but
yes, indeed.
Yeah, there seems to be some evidence for this. Yeah,
it could be spurious correlation.
Yeah, so if you were to take this a notch higher, it's probably worth looking at exposures on a per feature group basis.
I agree completely. We should really be graphing feature exposure across all of the features and comparing them using like a heat map and comparing like proportions and models and looking at it holistically like that, because we're just looking at the max. Where is that max? Is that max in intelligence, wisdom? Which group does that exposure lie? How many max feature exposures are there? We don't know that either, right? We're only looking at a single number which is the max, but we haven't identified what column it is. We don't know if every model has the same max, so there's still a lot of work to be done, but I hope that this gives a framework for people to experiment on their own. So this is like a first shot. This is feature neutralization 2.0, because 1.0 was using the OLS model and various proportions, the kind of naive basis of looking at, how much feature neutralization do we use. But now we can use different types of linear models and see what type of proportion works. and look deeper. And so I think feature neutralization 3.0 is down the road. But right now we need to learn how to move beyond feature neutralization 1.0 and kind of take it to the next level. Richard just said feature exposure is risk. The more feature exposure you have, the higher your risk. Fine. You saw what integration test has. Look at your own model without any feature neutralization. Do you have more feature exposure or less? Just at that naive level. Because Glimpse of the Future is saying the more I see integration test outperforming, the more skeptical I get about feature neutralization. Hey, skepticism is a good thing. But I believe Richard. I don't think he'd mislead us because that's not beneficial to him in any way. So if he says that feature exposure is risk, me being a risk-averse person, I kind of want to reduce that risk. And so feature neutralization is how you reduce your risk.
Well, when we say it's risk, and Richard says that it's risk, it's still just, a supposition that it's risk. So we're defining linear exposure to the features as a risk factor. But it's not an ironclad law. Certainly on
Correct.
the level of week to week, we've seen weeks where if you're probably not exposed to certain features, you're going to get killed. So the question is, over time, is it less risky or not? I think it is, but that doesn't mean you aren't going to get murdered being neutral sometimes.
I agree. We've seen.
And there's a little bit of, I think, confusion about the terms. You were talking about this before. So we talk about worse and better and all these relative words. The OLS model reduces at 100% in a naive way, eliminates the linear component completely. So that is 100% neutralization. So that's like the best linear model. So when JRB says the last Ridge is a worse model, it's not a worse Numerai model. It's a worse linear model that is doing the neutralization, which means you're doing less neutralization.
Yeah.
So any sort of regularization means the linear model is holding back some of its total magnitude or whatever, and therefore you are going to end up neutralizing less. So any sort of regularization is in some sense similar to playing with the proportion parameter in the very simple way. You're just...
Yeah, perhaps. We don't know how the coefficients are changing. So that's
I'm just saying in terms of the levels,
yeah.
It's not going to be the same effect exactly at all.
That's also why I encourage people to try the different implementations between Elastic Net.
Anything
Ridge.
you do, anything that you do is pulling back from full neutralization.
Yes.
There's no way to go beyond full neutralization. Like somebody was saying, why don't we make a negative? But then you're just betting on the reverse linear. So
Correct.
It's still linear.
Yeah. Also, do consider BudBot 7 long term. Like just right now, having feature neutralization is hurting, but they're not burning that bad. It's in the correlation space, if you remove MMC from this discussion, in correlation space, the feature neutral models aren't getting whacked that bad. It's pretty decent. So yeah, while it's a burn, it's not nearly as bad as it could have been. Integration test is outperforming, but that's because it has high feature exposure. When we talk about feature exposure and risk, so risk is volatility, right? So it's amplitude of your scores. If you have lower feature exposure, I would expect to have lower volatility for my correlation scores. I would expect that. Now, how do we know? We have to test it, and that's what these notebooks are trying to provide for you.
And we're just neutralizing to the given feature.
Correct.
So we're not necessarily neutralizing to hidden factors
Indeed.
that we aren't even aware of.
And I'm sure they are in the back end.
If you're resistant to the idea that we should be, knocking down these exposure to the factors, that is a normal impulse, and it's going to be right some of the time.
Yep.
So.
Yep. Exactly. So sometimes it helps to be feature neutral. Sometimes perhaps it just doesn't help.
I'm moving towards a balanced portfolio where I have a totally unneutralized integration test model that does well in those eras, and then I got a lot of neutral models that do other times. What I've seen over time, and this is not enough time to make a hard rule on it, is that in normal periods, it seems like both models will do okay. There are times when neutral models do okay and integration tests do okay. They're not both dominating, but they're all making money. And that seems to actually be the usual case over time. But then we get into these periods where if you're not on one or the other, you're getting killed. So it's a matter of what do you want to bet on? And I'm just trying to win on neutral models myself. And then when integration test is killing it, I'm trying to break even or only lose, 1% or something.
Well, I would endorse that kind of idea 100% because that would be an optimal way in a mean variance kind of environment to have uncorrelated models that perform well at different times. So that on balance, you're generally positive and different models are doing very well at different times. That would be a more ideal way of approaching it.
On an individual model basis, you could say there's no point in having a model which doesn't make money in the long run. But
Indeed.
There's actually an exception to that. But assuming that's true, it could be that you have a model that makes a lot for 2 weeks and loses for 10 weeks, but still is breaking even or eking out, which sort of hedges your levels of drawdown. And then you have other models which are going to be positive, 6 out of 10 weeks.
But Wiggle Me is what you're getting at.
But not as strongly.
You're getting very close to something that I think is critical here. We're missing one piece to this, and that is stake management. See what I did there, Anson?
Yes.
See what I did there?
Nice point.
See what I did there? Yeah.
He didn't see.
So we're now in the month of February, and so I bet we're back at 100% production on stake management, right?
Soon.
Well, I tried. I'm always going to fit that in there anywhere I can. So
Stake management, yes.
I'm working on a website which will show you what you're missing with stake management. So that will make it more imperative because people will look and say, be able to move their percentages around and see what it would be like.
Yeah.
Cool.
Senator Cap says, when stake management? Honeycomb says stakes as in the food. And Glimpse of Future has a question. Based on experience, are feature neutral and non-feature neutral models uncorrelated? I don't think I have enough data to fully answer that question. Hopefully we can collect some of it.
Somebody was saying something interesting about a theorem, or somebody had taught them that the OLS component of models is pretty much always the thing that makes models similar to each other. And that, in other words, if you get rid of the OLS, we've talked about this before, is there a feature neutral cluster? If you fully neutralize, does that mean your model is going to be like other people's feature neutralized models? And I think not. I mean, they are in some way, but they're not all going to correlate on the same scores. They might do relatively badly and well at the same times in a relative sense.
Yeah.
Because that's just how the tournament is structured. But are they actually similar? I think that when you get rid of the linear part of it, you're getting rid of the similarities, but keeping the differences. So it could well be that feature neutral models are actually more different than each other than non-neutralized models.
Right. And all of this begs some testing from the user base. And I would hope that some of you will do some testing on different proportions. Some of you will do testing on the same proportion, but different linear models being subtracted out, and various other combinations of that for a long time series, like 20 weeks. I don't have what the minimum number would be. You would say 30 for statistical.
We didn't even have enough weeks on NOMI yet to say anything about anything. So
exactly. So I'd like people to consider voluntarily eating up one of their spots to test this out and keep it consistent as long as possible.
Could I take a minute to defend linear models? I think
yes, of course.
Yeah. So as a community, I've been around for 4 or 5 years now.
You're an OG.
The Numerai community absolutely detests linear models, right? Someone said, "Oh my God, you have a linear model. you are so useless. That's the sort of attitude. But linear models are super useful, right?
Yes.
And I mean, what are neural nets
and
but
often
stacked
profitable.
linear models?
And often profitable. Yep.
Yeah. So I think even if you don't think about feature neutralization, it makes sense to spend some time trying to understand linear models, because I think understanding linear models is a key to understanding everything else in machine learning, right? There was a time before before neural nets where the only sort of big model you could train was a linear model, right?
Right.
So it's kind of
Perceptron.
SVMs and things. Yeah. So you would train a linear SVM with hand engineered features. So how do you make a linear model nonlinear? Give it nonlinear features.
Yep. Interaction terms that you create
Right.
yourself.
Yeah.
We still do that
to
in
this day-
econometrics.
Yeah. If you want to do feature selection, so you've engineered a bunch of features, you want to do feature selection. There's nothing better than a linear model. Yeah, you could use trees, but
Yep.
it's a bit more complicated.
Yep. Stepwise. I
So-
mean, leave one
Yeah.
out. All the
Yeah.
standard stuff
Mhm.
that we just take for granted is still used in academic research, at least in my field, finance. All this basic stuff is still the standard bearer of how we work and getting our panels ready for statistical analysis.
Yeah, so linear models are not evil, right? They're
Correct.
super useful, and it's definitely worth looking into.
Yep. So we're about out of time. Looks pretty good on the comment side. I will fix those notebooks so people can see them, or at
Hey,
least
the
figure out why
API
they're not.
updated finally.
Oh, okay. So we're getting close
Oh.
to scores. We won't have the full dealio for a little bit, but imminently, friends. So on that note, thanks everybody for coming in. JRB, especially thank you for helping me walk the folks through it all. And we'll make sure this video gets out for folks, and I'll try to cut out that portion where Twitch glitch, and get the notebooks working for folks. So thanks again, everybody. Have a great day.